Hi everyone. In the last video we introduced this idea of resistance, which is kind of our step one on our journey through DC electronics. And so now we want to talk about how we combine them together. Once we have multiple resistors in a circuit, how do we start to do some analysis? Now the intrinsic property associated with resistance is resistivity. It's the rho value here. I know that's the same symbol as density, and here it means resistivity. Basically, it's the resistive density of the material. It's the property of the material. Resistance is basically that intrinsic property multiplied by the length of the resistor. You know, the longer you have in a resistive path, the higher the resistance will go. The stronger the material, that's the resistivity. The stronger the material, the higher the resistance. The longer the resistive path, the higher the resistance. The bigger the cross-sectional area you have for the current to flow, that decreases resistance for the same reason that multiple lanes on a highway decrease the congestion. You have more ways for the electrons to move around one another, and so that cross-sectional area decreases resistance. And so this is basically this formula here connects the two together. And the reason I mention this now is because this formula actually allows us to understand why these two formulas are true. So if I have two resistors, I put them next to one another, connect them like this picture here. This is called putting the resistors together in series, because whenever the current flows, it has to flow through one and then the other. That's what it means to be in series. And so here the total resistance is simply the sum of the two, and that's because effectively I've increased the resistive path between point A and point B, for example, right? The resistive path is just increased. If I add a third, a fourth, a fifth, a sixth, it's just going to add more resistance. This situation here is called putting the resistors together in parallel. You know, there's two parallel lines of current in this case. And so here the current flows up and encounters this junction point and splits, right? And so I have a smaller amount of current flowing through here, a smaller amount of flowing through here. Now the total is the same. You know, whatever current starts here has to be here and then combine together at the end. But a parallel circuit splits current. And because of the way that this happens, essentially you've increased the cross-sectional area, which decreases the total resistance by this formula. And if you notice that basically the area is in the denominator here, and so the total resistances, their reciprocals actually add. And if you're to verify, this number is always smaller. The R is always smaller than R1 and R2, either one of them. And so this is how basically we define the equivalent resistance. We have a series of resistors, or a combination of resistors. The equivalent resistance is the total, this R. Now I can create more complex circuits. If I have three resistors, I can put three in series, I can put three in parallel, I can put two in series in parallel with one in different combinations, all sorts of things. And the trick in analyzing those situations is to find some pair of resistors somewhere in the circuit which are either in series or in parallel. Now it's not true that you will always find a pair like that. It's possible to have a circuit in which none of the resistors are in series or in parallel with one another. Those are complex circuits, and there are ways to analyze them using Kirchhoff's laws, but for our purposes, you'll always be presented with a situation where you have some combination. Find that pair. It's either in series or in parallel. Once you find that pair, collapse it, reduce it to its equivalent resistance, then find the next pair. There's either a resistor that's associated with it in series or in parallel with it. Find that, do it again and again and again, and basically collapse all the combination into one single number, which represents the total resistance of the circuit. And that's the equivalent resistance.